All right, it's recording. All right, here we go. So, last session we talked about chain rule. This session, still following a chain rule, but with all the other rules that you need to know. Now, all of these are already in your formula sheets towards the end of year. You do need to memorize these ones. So, the derivative of e to the x is itself. Know how to derive log, sine, cos, and tan, or cosine. And then you've got power rule, which most of us all know. Power rule is when your function is something of ax to the power of n. The derivative will then give you n times ax to the power of n minus 1. Let's see if you remember your chain rule. Here we go. Chain rule. Let's use the user-friendly formula again. What is the chain rule again? Let's go with Phoenix. Do you remember the chain rule? Beautiful. Delta y delta u times delta u delta x is the derivative for delta y delta x. Okay. These are your general rules that you need to know up until I. It's now only missing product rule and quotient rule. That's your last two exercises we're doing on Friday. Tomorrow we're going to look at derivative graphs, but just for up until this point here, I want you to be able to feel that you can find the derivative of each of these different functions. Let's do some examples. If you flip to the last page, which we didn't go through last session, there's a bunch of questions I picked out that you can try. That you can do in your exercise book. Check with your calculator as well. We're going to do just some VCA examples, and then I'll give you a little booklet that may have some overlaps in these ones here, just for you to try. But the aim is that you should feel confident if this came up, because that's a typical exam 1 type question, usually question 1, usually. Obviously now it doesn't have product or quotient, these ones I've chosen. But here we go, let's do the first one. This one's pretty straightforward. So, how do we know it's a chain rule? Well, we've got an exponential function, starts with an e, but instead of an x, instead of it being e to the x, we've got now e to the x squared minus x plus 3. If we look at our rules, we've got this, e to the x. If it was e to the x, then I know the derivative of that is itself. What's the problem? The problem is not just e to the x, it's e to the, and there's a quadratic expression there. So that's a problem. So what we do in chain rules, we say, let's reintroduce, let's pretend that is just one variable. So we say, let this entire expression, let it equal to u. So u equals to x squared minus x plus 3. Okay, so this is I'm going to do the long way, and eventually, hopefully you guys do this shorter way eventually. The long way is that you're defining this as u, and that changes the problem to f of x now becomes e to the u, or technically it's f of u. Okay? So there's a function in terms of u, and this we can find the derivative. This we can then say the derivative of that is f dash of u. So this is what they call deriving the outside, because you're almost ignoring x squared minus x plus 3, and you're just focusing on the entire function. You say find the derivative e to the u. This should give itself e to the u, based on the previous rules that we've got. But don't forget, we did also make up a random variable. We said let u equal to x squared minus x minus 3. So here, this is where technically that's your delta u delta x. This is your delta y delta u. This is your delta u delta x. So according to chain rule, we said it was delta y delta u times then delta u delta x. So I just need to find the derivative of x squared minus x minus 3. And let's see, what would that give me? Can I go with Aryan? What's the derivative of x squared minus x minus 3? Good. That becomes 2x. Beautiful. And then obviously derivative of any constant is 0. So yes, you get 2x minus 1. So that's your delta u delta x. Derivative of e to the u is just e to the u. So putting them together, delta y delta x, which in our case is the derivative of f of x, so f dash of x will equal to, and it should be e to the u But since we knew u is x squared minus x plus 3, so e to the u, multiplied to delta u delta x, which is 2x minus 1. Okay? And at that point, this is your mark, but remember the question saying evaluate the derivative at x equals 1. So technically you haven't actually got your mark yet, so there's probably 1 mark to get there. And then finding f dash of 1 becomes e to the 1 minus 1 cancels out, so e to the 3 times 2 times 1 is 2 minus 1. Works out to be e to the 3. Okay. But you can see that this is the long way of doing it. You let u and then derive u, and then you derive the delta y delta x, and you times them together. Eventually, what you want to be able to do is to do this in your head, and you just simply derive x squared minus x plus 3, which is then 2x minus 1 here. And then you derive e to the u, so you almost ignore that blue highlight that I've got there. So derivative e to the u then gives you the first term over here. Okay, so that's what they mean by derive outside, derive inside. So if I do that, let's try to do derive outside, derive inside quickly with logs. Here we go. What's my inside here for the second problem? Can I please have Samar? What's the inside function? Good. So this is the one we're going to derive inside. So we're going to do outside, inside. Here we go. Outside times inside. Then we're going to derive the inside. So the derivative of x squared plus 1, in this case, gives me what? Can I please have Una? What's the derivative of x squared plus 1? Beautiful. 2x. Derivative of 1 is it's constant, so it's 0. Derivative of x squared, power rule, so it's 2x. And now we do the derivative of the outside. So it's almost like we ignore that x squared plus 1 even exists. I'm just asking, what's the derivative log e of something? This is where you go back to your 6 rules that I've given to you so far. So if you go back to the previous page, log e of x, so log e of something, derivative of that is 1 on something. So in that case, the answer is, since it's log e of x squared plus 1, then the answer, the derivative of that should be 1 on x squared plus 1. Okay, and that's what they mean by derive the outside. So this is the outside. You almost ignore what's the x squared plus 1, and you derive the inside, and then you times those two together. That's essentially delta y delta u, and this is delta u delta x. Okay? So this is like your delta y delta u, and this is like your delta u delta x. So together, put them together, multiply them together, and we can see that you get 2x over x squared plus 1. A typical mistake here is that some students will then do this. Why is that wrong? Why is my last step wrong? I see that quite a bit here and there, even on a sack. Why can't I cross those two off?
Is it because there's a coefficient in front of x?
No, not because of the coefficient. You can have the coefficient and it's still fine. Or I can take off the coefficient and it still can't do that. Beautiful. That plus. You can't separate those two. It's only if it's times. If it was times, it's fair call. You could do x over x. Let's say there was a 2 there. It was a times 2. Whoops. You can simplify it. The reason being is because you can separate the fraction. The fraction ends up being x over x times 1 over 2. See that? X times 1 is still x, and then x times 2 is still the same on the denominator. X over x, yes, you can. That's why it works to do that. But why can't you do it if it was x over x plus 2? Because x over x plus 2 is not the same as writing x over x plus x over 2. Because we know, adding fractions, they have to be the same type of fractions. It's not the same denominator. So you can't say, oh yeah, x plus 2 is on the bottom, and then therefore x plus 1. You can't do that. So you can't take this same assumption and say, yep, I can just cross those two off. It's not. That's one denominator. And they come in 2 terms. So what makes it clear? It's that addition. Any add or subtract, you can't cross them off. Only when it's times or divide, then you can. Okay, and it's just based on your fraction rules or skills that you did back in whenever you learnt it. All right, so that's a common mistake I usually see students do. They will just cross off the x's. So really, that last bit is wrong. The correct answer is you just got to leave it. 2x over x squared plus 1. Okay? But we still haven't got our full marks yet because it actually says f dash of 2. So f dash of 2 would then equal to 2 times 2 over 2 squared plus 1. That's 4 over 5. Coolies. All right? So the idea is that I want you to practice the 6 rules that I gave on the previous page, and I want you to practice that inside, outside, inside, outside. You want to get very familiar no matter which way I give it to you. So if you look at the examples I've given to you, I've given you some with fractions. I've given some with surds, because those are common. What are the ones they like to do in exams? Logs and circular functions. So I just combined them in there for you to practice and try. Check out with your calculator. The more confident you are with those, at least you know you're securing about 2, maybe 3 if it's a trickier one, but usually 2 marks. 1 to 2 marks in the first question out of your 40 marks. That's a good one to practice. What's one to teach you? This one you need to know quotient or product. Technically you don't. If you wanted to do this, you can do it without quotient by writing it as e to the x times cos of x all to the power of negative 1. Oh, but then you still need to know product rule. Forget about what I said. You still need to know product rule anyway. All right. What's one that you might normally see that you don't know how to do? Let's do this one. C. So C, if you got some space somewhere, which I think on your notes you should have an extra blank piece of paper, you can write this one in. So y equals to e to the 2x minus e to the x plus 1 all over e to the x. How do we derive this? One of the common mistakes I see students do, this is another common mistake. So they're like, cool, I've got a fraction. All good, because I've got my rules that Mr. Tran gave to me, which is over here. And I know that e to the x is itself. So they go, all right, well, let's do it. Derivative of this one is e to the x. So they write the next one. They go, all right, delta y, delta x. E to the x on the bottom is e to the x. They're like, oh, yeah, that's the same thing as well. So derive this one. That's also e to the x, so minus e to the x. Derivative 1 cancels out, so it's plus 0. And then they go, derive this, e to the 2x. And if they've used their textbook rules, they'll know it's 2e to the 2x. And they're like, yep, that's my answer. Why can't you do that? What's wrong with applying what they just said? Because the rules work. Derivative of e to the x is e to the x. Derivative 1 is 0. Derivative e to the x is itself. And the derivative of e to the 2x is 2e to the x. Why is this wrong? Why can't we do it? Anyone have a clue? Leo.
We're treating each term with its own power, using power, whereas like here the 2x is actually e to the x, you're dividing e to the 2x. Divide e to the x.
Beautiful. The rules that we've given to you here is their actual term. So the key word is term. Term is separated by a plus or minus sign. Yes, you are separated by a plus or minus sign here, but you're also ignoring the fact that it's dividing e to the x. So if you actually want to separate them to the terms, just like Leo said, if we separate into terms, this is what it would technically look like. It should look like e to the 2x over e to the x, because that's the denominator. You're going to divide it by e to the x. That term is also going to divide by e to the x. So it should be minus e to the x over e to the x. And then this one is plus 1, but it's also going to divide e to the x. So it's plus 1 over e to the x. That's a term. This is a term. So you got 3 terms. You got 1 term, 2 terms, 3 terms. So now if you want to apply the rule, yeah, you apply it to this, but you don't apply it to numerator, denominator individually. They are 1 term. But this 1 term is not the same as the rule that I gave to you in those 6 rules. Yeah, so this is where the technique is then you simplify that. Let's make it something that's more familiar. Well, e to the 2x divided by e to the x, you can use index laws. They share the same base, different powers. But if you divide, what do you do to the powers again? Subtract. Yeah, very good. So this would be e to the 2x minus x, and then becomes e to the x, or I'll just write the proper working out. So 2x minus x. That gives you e to the x. And then this one, this is e to the x divided by e to the x, which we already know is going to be 1. So this is minus 1. And then this one, yes, it looks a bit funny, but we can use index laws again. It's in the denominator. Bring it up, and it becomes e to the negative x. Now you can use your index laws. Oh, sorry, your derivative laws. So this is your new y value, or y expression. So that fractional expression for y is now like this. Now you can apply individually. That's okay. Derivative e to the x, derivative of e to the x, and then derivative of 1. There's 3 of them that you find the derivative of. And conveniently, in this case, now we can say e to the x, derivative of that is e to the x. Derivative of 1 is 0, so that cancels out. And then derivative of e to the x again is itself. Oh, wow. It actually turns out to be e to the x minus e to the x is 0. So 0 gradient. Stationary point. How about that? Okay. So that's what I'm trying to illustrate, the two differences between the two. This one's the correct answer. So simplify. When you get these fractions, break it apart, simplify them down. Okay. And usually if it's exponential, you use index laws. If it's power functions, you still use index laws as well. So similar idea. But the idea is separating them. And the reason why you have to separate them, because you can't forget there's the division. Okay, each one has a factor there. If it had not had the division, then fair call. All right. All right, team. And what's another one that normally stumps students? Surds. Practice those ones. Those back in the past, between 2010 to 2015, kids really struggled with that. They got better over the years, so I don't think that is much of a thing. But I do know students in year 11, when I first test them, they hate the surds. Worthwhile trying. And again, it's just changing the look of it. This is the same thing as saying e to the x plus 1, and square root is the same thing as power of half. So if you follow the same idea, inside versus outside, this is your inside, derive that, derive the outside, so pretend this never existed. It's u to the power of half, and then derive that. You should be fine, but just getting used to working with fractional powers and then minusing 1. Sometimes students get a bit ticked off by that. Okay? And then other ones, logs. Why are logs nice? Because you have to do the fraction. Anything to do with fractions, students make mistakes. So practice the logs, practice the chain rule. All right. I'm going to hand out a sheet. And it's just to add in a few more VCA questions for you to try. I think you can probably practice the ones I've written here. If you can do that, that's pretty good. Do the worksheet if you like. Do some VCA questions if you like. And you still feel like you need more practice, 9F to I. Okay, 9F to I will then have a bit more. But I think that should be pretty sufficient. Just move on. Yeah? All right, let's stop the video.